Alright, I just noticed that my mic is live and I have not switched scenes. There we go. Alright, welcome to another optional lecture. We have, even though I'm still in, like my brand new office here, there's a little gremlin just off screen over there. If you hear some strange noises, just ignore it, okay? This is going to be an example from variation of parameters, alright? This is the method that we have kind of learned. Our impetus to this was to say, how do I find particular solutions when P of t and Q of t in our big second order differential equations, when those depend on time. It can also be used when normal methods, like say in this case, method of undetermined coefficients, is not going to help us to find a particular solution. As we're going to do that example here right now. And specifically, I'm getting past the trick of, do I know what x1 and x2 are? Because I know how to solve this homogeneous equation. So first off, we look over there. There's no x prime, so there's no p of t. Our q of t is 9, so it's a constant. We might want to try method of undetermined coefficients to find my particular solution. Now, if I look at that, I've got 3 secant of 3t. Okay? I could try to guess. This gremlin is looking at me like she wants to eat me. Hey, what's up? But if I guess 3 secant of 3t for x, or a secant of 3t, excuse me, then my x prime is going to be equal to, let's see if I can remember this before it comes up on screen, 3a something of 3t tangent of 3t. Secant of 3t tangent of 3t, that's what it is, yeah. That equals x prime. And x double prime, I just don't want to do that. I don't want to embarrass myself. Just way too many terms. And we can already see right there, if I'm looking at that, that means 3a tangent of 3t, at least that, has to equal the number 3. All right? That sounds tricky because then a is a function of time, and this step between here and here is just wrong. So we can't even try method of undetermined coefficients to find my particular solution. All right? So we're going to use variation of parameters. And the first step to that is to find the solutions to the associated homogeneous problem like we got over here, x double prime plus 9x equals 0. Assuming that x equals either lambda t, we get our characteristic polynomial of lambda squared plus 9 equals 0, which gives me that lambda equals plus or minus 3i. What's up, homie? Purely imaginary, which means we have no exponential components, and so my solutions are cosine of 3t and sine of 3t. Ultimately, it doesn't matter which one of those you make x1 or x2, you just want to be consistent. Once you've made one of them x2, like here I've said x1 is cosine of 3t and x2 is sine of 3t, it always has to be that. Don't change your mind later, okay? Because everything hinges on that. That means my homogeneous solution in general is just a linear combination of those two things, c1 times x1 plus c2 times x2. That's easy peasy. All right, but now we're going to use variation of parameters to try to get a hold of what my particular solution is. All right, so that means assuming that we have unknown functions u1 and u2, and in working through all those formulas like we did in the video, bless you, we have to find the Wronskian. Okay, the Wronskian is x1, x2 prime minus x1 prime, x2, and we can do that with our equations right here. So x1 is cosine of 3t, and x2 prime is 3 cosine of 3t. Cool, I can write that down slowly. I write very slowly with the stylus. I don't know if you guys have tried it before. Now we're going to go minus. Now x1 prime, that's going to be negative 3 sine of 3t. Everybody get that there? Because the derivative of cosine is negative sine. Okay, and then we have a sine of 3t. So you know what? We might as well put a squared right there. Yeah, I did it. So I have 3 cosine squared 3t plus 3 sine squared of 3t. I hope that we're all kind of at a stage right now where we see a cosine squared and a sine squared with the same argument inside. We automatically know this is the number 1. So my Wronskian is 3. Girl, I'm trying to shoot a video. Yeah, that's right. Hush your mouth. All right, so we are going to assume my particular solution is u1 x1 of t plus u2 x2 of t. And what our job is we to find out what u1 and u2 are. We already did all the work in the previous video of learning those solutions, so we can just use those formulas, okay? So u1 is equivalent to, getting ready to write it now. Why did I pause so long? There we go. Negative the antiderivative of f times x2 Did my video pause? I'm not editing it. I've had so many takes on this. You're just going to have to deal with it. Yeah, okay. X2 divided by W, which is our Wronskian dt. And U2 is equal to the antiderivative of f x1 over W dt. Right, the W. There we go. dt. Now, what's great is I know what f is. I know what x1 is. I know what x2 is. And I know what W is. I can plug those bad boys in. Right? So let's plug in for U1 right here. U1 of t. Why, that's going to equal negative, now f was our 3 secant of 3t, right? And if I remember correctly, x2 is our sine of 3t. This is why the order which you put them in is important. You need to be consistent. And our Wronskian is the number 3, dt. So what this is going to wind up being is negative the antiderivative of tangent of 3t. If you remember the definitions of, well, secant's 1 over cosine, so we have sine over cosine right there. Okay, do you remember what that integral is? I don't remember what that is. Table of integrals is your friend. Okay, but we got 1/3 the ln of cosine. You cool? Of 3t. Okay, so that's my unknown function. That's my u1 that's going to be multiplied by x1 in order to get my particular solution. So u2 equals the integral of 3 secant of 3t again, because that's what f is. Now cosine of 3t, because that's what x1 is. And we're going to divide that by 3, because that's what our Wronskian worked out to be, that big W, with respect to t. Notice those 3's cancel out. Secant, again, is 1 over cosine. So cosine times 1 over cosine, that's the magic number 1. So that coefficient is actually quite simple. It's t. Let's put all this together now to find our general solution. It's c1 cosine of 3t, because that's my x1, plus c2 sine of 3t, because that was what my x2 was, plus u1, close parentheses, there we go, u1, which is 1/3 the ln of cosine of 3t. What? What, you little monster? All right, and then that's going to be multiplied by the 3 cosine of 3t, because that's what my x1 is. So notice that cosine of 3t is the same as the one that my hand just disappeared over touching the c1. And then you have a plus t sine 3t, because that's my u2 and my x2. Okay, thank you guys so much for watching this. I hope this helps you guys approach this. See you later. I gotta put the stop button.